So now about DeepSpar Disk Imager. This is our main product, I should say, key product. And this is data recovery hardware imager. Okay, it's built as a PCI Express card that works on a PC platform. Unfortunately, it doesn't work on Mac. Many of you are successfully using this product. So if don't trust me on word, okay, try to find someone in your community who is using, and we have many of you who are using our product, DDI in particular, and we have not a single client who is unhappy, not a single. Okay, so everybody is happy, and everybody is saying that the product pays for itself, well, right away. Okay, because you cannot really, you just have to outsource all these jobs just because of disk level issues. Okay, this guy is being used by professional data recovery industry. Okay, this is specifically intended for data recovery industry to handle disk level issues. So what it is, it's a combination of hardware and software to retrieve data from unstable drives. Okay, it is its purpose. It's hardware imaging with no reliance on system software. We have a proprietary operating system that boots from DOS. But also don't be confused. We only use DOS as a bootable device to load our application. As soon as DOS loaded, we basically reconfigure the system to our proprietary operating system. We use 32-bit proprietary operating system, so up to 4 GB of memory and things like that. Now, it's a custom ATA controller under the proprietary operating system, as I said. And the it's a PCI Express card with software hardware add-ons running on PC platform. So we have a number of add-ons. I don't want to get into every particular add-on, but just most importantly that you may be interested in, we have a USB add-on. It's a separate USB card, PCI Express card, to handle USB drives. Especially those that have built-in USB connector. You know that, right? Like Western Digital, Seagate have, Samsung has, Toshiba has. It's a laptop drive that has a built-in USB connector, and you cannot connect it to any SATA port. So, and we have a special add-on. It's a special PCI Express board that plugged into the same system where DDI is, okay? And it will have extra USB 3 connector. So then you can process those media issues or read instability issues with those USB drives. But if this is desktop drives, the right way would be just to get the drive, SATA drives outside of enclosure, create an image using DDI, and then take that image and put it back to enclosure and copy data off. Okay, but with built-in USB, you cannot do that. And what else? We have current monitoring add-on. It's a firmware add-on that helps you to diagnose electronical problem of the drive and some mechanical problem. This is very useful, and when we have a lab session, I'll show you how it looks like. But basically, it's a good resource to find easy fixable drives. By easy fixable, I mean, for instance, a drive that has just a burnt fuse. You know, like let's say the drive, all laptop drives, by the way, has a fuse, right? Just on the board itself, okay? And it's easily identifiable. This is the first component that goes to power socket, okay? It's just a regular fuse, and it burned, and after that, the drive doesn't spin. But when the drive doesn't spin, you don't know what's wrong with it. It could be a fuse, could be motor, right? It could be like head sticking to this platter, lots of issues. So we have that current monitor add-on that helps you to identify whether it's a problem with the fuse, whether it's a problem with the motor seizure, and lots of things. So and again, it helps a lot to identify issues because when you know what it is, you will know what to do. I'm not telling you that you're going, you know, to the clean room and setting up clean room, opening up the drives. I will never recommend you to do that without proper, you know, tools and training. But with DDI, you can have, you know, diagnostic capabilities to at least know what's wrong with the drive, right? And we have forensics add-on, but this is for forensics world, probably not for you. It has all those features that required for forensics. For instance, like a forensics report that will build and list all the fragments that belong to each file and report all the bad sectors that may be affected this file. So it's a huge reporting tool. okay, for forensics industry. And the last, but the most valuable add-on is network add-on. Network add-on, it's a firmware add-on that gives you functionality to connect to DDI from Windows system. Okay, we have application that's called DeepSpar recovery environment, and you can control multiple DDI systems in your LAN from one platform. Okay, so that's very helpful, especially for processing drives with lots of instability issues, because you can then image by file. By using network add-on, you can image file by file rather than imaging the entire drive. Okay, so you can image just metadata, for instance, build a file tree, select critical file that your client is looking for, and just image file by file. And everything is done from the Windows on the Windows user interface that control DDI on the fly. So it's basically you see the files, all the file that needed, and DRE is just imaging one fragment of the file at a time and then build the entire file. Okay. And it boots up from a provided USB stick, as I said. Okay, yeah?
Sir, can you explain how that happens, how it's able to do that? I mean, on a Mac platform specifically, what's it need to get from the drive in order to be able to build that directory tree so you can selectively try and recover files?
You mean the process itself, how it's done?
Or do you have a booth tonight?
Yeah, well, I'm planning to do that in lab session, just after my presentation. Okay, because I have DDI here, set up DDI, so I'll just show you on the screen how it looks like. Okay, I'll show you briefly, but now I just want to go through the theory. Okay. So handling these level issues, the first thing that we should understand is that problem that when you send the command to the drive, the system software is waiting for the drive to respond, right? And the first capability that I would select from any hardware data recovery imaging tool is ability to reset the drive, to have so-called read timeout. So that's the first thing. If I ever selected any hardware imager, I would first ask the vendor, do you have read timeout? Do you have ability to reset processing of the drive and send the next command to read the next block? Okay, so that's the most critical. And why? Because this is what's happening. So if we have host sends a command and wait for response, right, infinitely. So it waits, and waits, and waits, and waits, right? And there's nothing happening, and it still waits, and the drive starts unnecessary internal processes. Okay, this is what it looks like, what drive does. Okay, and we still wait. Okay, and the host still wait, and the drive does this. And if you really look what's happening, you would see exactly what it is. Because the drive is crazy. When it has a bad sector, it doesn't know what to do. Okay, it just started doing crazy things, and that's why that needs to be aborted as soon as possible. Okay, we should not leave it running like this. Okay, so that's really the first thing that makes the hardware disk imager a professional tool. Okay. So that's why what we should do, the first thing we should do, we should reset processing and move to the next block. Okay, and this is what software cannot do. Software doesn't do this. Okay, so with the hardware imager, we can just set, okay, there is a read timeout. Let's say I know that any good block is being read with that, I don't know, maximum like 10 milliseconds, for instance, right? And if it takes more than 10 milliseconds for the drive to respond, I know there is a problem with this block. Okay, that's the mindset, right? So why would I want for the drive to harm yourself if I know there is a problem with this drop? So we can skip it. We can reset, abort this processing, and say, okay, look, leave it for now. I'm not saying that we will just leave the entire block forever. I'm just saying that leave it for now, okay? Because we have to be safe, okay? We have to do safe things first. So we move to the next block, and thus we're retrieving all good areas first, okay? So that's the idea behind this read timeout. The idea is that we are identifying problematic areas on the drive and skipping them so that we get back to them if necessary, right? Because at the end of all, that clients usually need what? They just usually need maximum 10% of the drive, right? Maybe even less than that. Because all they need only their critical file. They don't care about operating system. They can reinstall this, right? They don't care about the drive usually. All they need that QuickBook files, or whatever, or files, documents, spreadsheet, whatever. So if we have ability to read good data first, good block, and skip all the bad, what we're doing, we're making the entire imaging process very safe. Okay, and we get everything possible from good areas. And maybe everything that your client needs is those good areas. Maybe you don't even need to handle this. So basically, that's why the most critical thing is to be able to skip all those problematic areas. To skip, only to get all good ones and see if that's exactly what you need. If you need something in bad areas, only then you will dig into those bad areas and then get what is needed. Okay, so that's kind of the idea behind the right way with hardware disk imaging.